So we're going to talk about preventing lateral movement in Windows virtual estates. So a bit of a security focused piece of stuff, because I mean, as everybody's probably quite aware, right, security is very much a big thing these days. Security teams are always busting our ass about one thing or another that they're complaining about and ruining the performance of our desktops and virtual desktops with all of their agents and whatnot. So let's talk about that a bit. Just quickly, a bit of a bump about me. I've got my Twitter handle there, my website, james-rankin.com. I do have a YouTube channel which is actually monetized now, which means my kids think I am really, really cool, and rather weirdly some of my kids' schoolmates go stalking my YouTube videos and putting bizarre comments on them and things like that. So I have threatened to hack their TikTok accounts and fill them full of things that shouldn't be there, which I probably can't do, but they don't know I can't do that, right? So it stops them from behaving like that. I have also noticed I've left the notes in from a different session on that slide there, so that's rather disconcerting. I nearly went on a complete tangent there. Anyway, so let's talk about sort of kind of the sort of background about why, you know, you should be thinking about lateral movement from a security thing. And like I said before, right, security appears to be very much kind of back on the menu now, right? A lot of the time, you know, over the last sort of few years, we did a lot of talking about user experience, but now security seems to have come back to the fore. And I remember when GDPR came in, right, everybody thought they were going to have to start taking security seriously again. And, you know, certainly GDPR has the capability to threaten you with, you know, vast fines as part of your operating revenue if you don't get your security right. Whether they actually do that or not is a matter of question. But it's not just that kind of revenue loss from GDPR you talk about, right? What also you do is you could lose revenue because you'd have to pay a great big ransom to hackers or something like that. Or the other thing is basically mud sticks, right, when it comes to security. Now, it's quite interesting. Every March, I think it's about March the 20th, I get a load of notifications on my phone from loads of people on LinkedIn saying happy birthday, and every year I kind of have to tell them it's actually not my birthday because LinkedIn had a data breach, so I made sure I didn't give them the right details. So as a result of LinkedIn having a data breach and that sticking in my mind that they weren't being very secure with their data, I then get a reminder of that every year with a stack of birthday invitations when it's not my birthday. But I mean, it can go further than just reputational damage, right? I think CodeSpaces were almost the poster boy for how bad a breach can be for you, because CodeSpaces literally went out of business, right? So at the end of the day, the risk is quite large. If you get it really, really wrong, if you don't get your security right, you can end up completely and utterly out of business, which I guess is bad. So when you start talking about security, right, one of the basic principles that we have these days is about defense in depth, right? So you've got multiple layers of protection to detect or stop or mitigate intrusions within your network. And one of the sort of analogies that I always used about this was, if you imagine somebody who's got an expensive watch, right, and they leave it in their jeans pocket or whatnot when they put it through the wash, and it doesn't get checked and it goes through the wash and it gets broken, it gets ruined, and you kind of say whose fault is it? Is it the person who left it in there, or is it the fault of the person who didn't check? Well, the answer is it's both their faults, right, because they're supposed to help each other out there, and that's the principle behind a defense in depth kind of strategy, right? That you have these multiple layers of protection, and if one of them fails, one of your mitigation fails, or more of the layers of mitigation fail, the other ones will cover up for it. And you have to kind of embrace that principle of defense in depth, because, you know, an attacker is going to get past some of your defenses, right? Whether they get past it by being clever, by being skillful, or being lucky, right? And it's vital that you give yourself other chances to mitigate the attacks. And it's a very important concept, and I do apologise if I keep saying defence in depth constantly throughout this presentation. But when it comes to stopping lateral movement, you've got to adopt a defence in depth strategy, because, as I say, a savvy attacker will get around some of the obstacles that you put in their way. The other principle that I hear a lot of talk about is zero trust, right, which is the idea that no user or device should ever be automatically trusted, right? Whether it's inside or outside your network, it should never be automatically trusted. And when you think about the kind of zero trust access, I think from our perspective, and particularly from what I'm talking about here, is to talk about administrative access, right? Because at the end of the day, right, you've got to take into account the fact that an administrative account will eventually be used in some form of attack. I remember years ago there was a guy I used to be on a mailing list with back in the days when mailing lists were the way that we collaborated in the IT field. There's a guy called Ed Crowley, and who always used to say a kind of quote that became a tribute to him. He said there's not really technical solutions to behavioural issues, and his sort of stance was that if your users are going to screw you over, they'll use a phone, they'll write it down, they'll remember it, right? So you shouldn't really waste all your technical power on trying to mitigate that, and you should leave it to HR to hire better people who aren't, basically criminals at the end of the day. But I don't think that kind of still stands up today, sort of mainly for the reason, that under things like GDPR, you have a responsibility to make sure that once somebody breaches in your network, you've got to report it, you've got to be able to analyse it, you've got to be able to tell them what the scope of that intrusion is. So I think, basically saying that, especially from an admin perspective, that if it's an admin attacking you, then all bets are off. We've got to kind of get away from that mindset, and we've got to think about and deal with the capability, the possibility that we will get attacked by a rogue admin account in some way. So I think that's, especially when it comes to talking about lateral movement, admin accounts are the accounts that have the most capability to do things like lateral movement. So they're the ones that you've got to think quite a lot about. So, if we get on to the actual subject of lateral movement itself, what do we actually mean by lateral movement? If you get the kind of security definition from the internet, it says lateral movement is the ability of an attacker who's already gained a foothold in the network, or what the security boards call a beachhead into an enterprise network, to basically pivot, to kind of swivel around and extend the reach of the compromise that they have, right? So moving laterally means they're moving between resources that are similar or that share underlying services. And what they do as they move laterally is that they attempt further exploits and further intrusions or reconnaissance or data gathering on other devices and attempt to gain access to other more valuable resources, right? And the exploits that they can attempt when they're kind of traversing laterally through your network can be a wide range of things, from human identity through to unpatched vulnerabilities. Now, this is an actual quote from a report on the anatomy of a cyber attack that was done by PwC for the health and safety executive in Ireland. And you can see it mentions that they had an unsegmented flat network, which was designed to make it easy for people to access the IT applications that they need. And if you go right down, it basically says that the nature of this network enabled the attacker to access a multitude of systems across many organisations and create a large-scale impact in that way. So basically, by not stopping the lateral movement capability that the attacker had within their network, it allowed them to escalate their intrusion to the state that it had a very large-scale impact and ended up in quite a significant material loss for the HSE out there in Ireland, which obviously wasn't very good. So the point I'm trying to make is that lateral movement is an issue that you need to be aware of. And, if you've got if you kind of dissect the anatomy of an attack, you have kind of the initial foothold into the network. And, we're very used to trying stopping that initial foothold into the network, right? We patch our systems, we tell our users not to click on email links, we give them sort of training to try and make sure that they can identify dodgy emails and things like that. We do lots of stuff, like securing browsing and stuff like that. We really try and stop that initial foothold. And there's also kind of the end of an attack, which is where an attacker finally, deploys his ransomware or steals your data or whatever it is that he do. And we have lots of things that are designed to mitigate against that, right? Loads of DLP stuff, you block removable drives, things like that. You stop people forwarding emails and FTP and things in and out of the network. But the lateral movement sits in the middle of this, and this is kind of what an attacker does between getting in and between actually executing the kind of the final sort of coup de grace, as it were. But obviously it is much better to detect an attacker who is in the network and sort of moving laterally through it, as to finding out right at the end that they've got away and stolen all of your data, right? So it needs to be a part of your defence strategy to try and detect this kind of lateral movement as somebody that's inside your network. I don't know, I work primarily in financial services, right? We have teams embedded inside the network from CISO who are actually trying to replicate this kind of lateral movement, these kind of attack patterns, to see if they can be detected. So it's very important to do it. And you have to remember, right, you've got to take the approach that you will be compromised at some point eventually. So, you've got to assume that at some point there will be an active attacker in your environment. And it's much better to spot them in this phase rather than when they reach the end phase, or even just slow them down, right? Because at the end of the day, if you slow them down, you've got more chance of detecting them, you've got more chance of stopping them before they deploy ransomware or something like that. So like I said, lateral movements, such as we've mentioned, moving between similar devices, is similarly, focuses a lot on administrators, because people who have admin access have that capability to move laterally through a network, basically as part of their job, right? So a lot of admin accounts, such as the help desk, right, often have, rights to whole swathes of, virtual desktops, laptops, workstations, things like that, and they allow them to connect to those devices and assist them with case closures. Now, if one of these gets compromised, it's going to give you an issue. And I think it's very important to think about how your users actually do their adminning, because it's important if you want to try and stop an attacker's capability to move laterally through the network. You've got to try and make them do that administration in different ways. So just to demonstrate, right, when an administrator can move laterally, the potential for that sort of scope increase of your breach increases too. So imagine an admin account, it's got rights to a load of virtual desktops and it gets compromised, right? So now you've got an attacker that's potentially got admin credentials to 100 or 1,000 or even more sort of virtual desktops. Now, if just one of those virtual desktops, right, has maybe missed a patch that explodes as a critical flaw, that's when he gets to escalate his privilege, right? And now, is he going to gain a foothold? Is he going to gain access to a database server, a network device, even something like a domain admin account, right? So these footholds can move quite quickly through all those other levels, and even the attacker can end up start covering his tracks at his goes. So it's important to try and stop it at the first level possible, right? And I know that people are going to say, right, the problem is that you've missed a patch rather than that somebody's got a hold of the admin credentials. But at the end of the day, that's why we talk about the defense in depth, right? If one of your defenses fails, if somebody fails to put a patch, then there has to be other things in place to try and stop that as it goes forward. So in this instance, right, the answer is, if there's something there with a missed patch, you have to put something in that mitigates that administrator's scope to log on to all those hundreds or thousands of different desktops at that same time with one single credential. Now, what you've got to do, right, is you've got to kind of also understand what kind of lateral movement is actually going on in your network, right? So you're going to have all sorts of network movement in a network, and you've got what you might call upstream movement, which is users connecting to like file servers, databases, web services, and things like that. That's not lateral movement. Like we said, we're much more interested in users jumping around to devices of the same type, such as connecting to shares on virtual desktops or launching RDP connections. And I mean, you still need to be kind of concerned with that kind of upstream traffic. But with lateral movement, you really want to be looking at more of the same. Now, as I said, the user estate, whether that's virtual desktop, workstations, laptops, that is the place to start looking at how the lateral movement is happening, because that's generally where most of your threats will gain their initial foothold, although not exclusively, right? So the things that I tend to take an interest in when trying to map out lateral movement is people who are looking at file and printer sharing, RDP, Windows remote management, things like that, right? Have a look at how these things are being used in your environment. And what you do when you map out how these things are being used, it's important to go back and say to people, is there a reason you're doing this, right? I mean, I often, when I go into environments, one of the things that always strikes me is the amount of open RDP that's in use. People are just jumping from RDP, and these are not administrators doing RDP around. I've seen lots of cases. I mean, I remember working somewhere where they had thousands of Windows 7 machines, just basically Windows 7 VMs, and people were RDPing directly to them and using them as virtual desktops, sort of cheap and cheerful virtual desktops, which is not very, very good. I've seen developers, setting up file shares on their machines so that their fellow developers could share files with them, and they had some really interesting installers and lots of user data all shared out on those machines, right? And these are all threats that you need to lock down. I mean, particularly that sort of sharing of the data, because I mean, in that case, the attacker doesn't even need to escalate to get a hold of that sort of data, right? It was sat there for anybody to be able to go there and look. So you need to do this kind of discovery, because you'll find potential security snafus that attackers will look to exploit very readily. There's also, I noticed, Microsoft have a tool now, part of the Windows Defender for Identity suite now, called Lateral Movement Paths, that will identify them for you and help you out with that. So there is some automation you can do around that as well. So once you've kind of started to get in and analyse what sort of lateral movement's going on in your environment and started to sort of push back a bit and challenge, like I said, what we have to do as well though is just make sure that once you analyse those patterns and map them out, you've got to try and identify, are you going to stop users from doing their administration in a certain way? I mean, I did a presentation a few years ago about trying to balance the usability of a user session with the security of a user session. But the mitigations that stop lateral movement are much more likely to stop the admins doing admin tasks rather than users using applications. So I think what you have to do is, for every admin task you see where admins are jumping in RDP into machines and things like that, is identify what they're actually doing, what they're trying to achieve, and see if there's a better way, which we'll talk more about towards the end of this. Is there any better way they can administer that makes your job easier when it comes to stopping lateral movement? So there are lots of things you can do to cut down on that lateral movement, and most of these are kind of like they fold into that defense in depth strategy. A lot of them kind of overlap on each other. Obviously you've got to do a lot of auditing, network segregation, firewalls, you can use group policy objects and Intune to lock things down even further, password control, privileged access management, restriction of user access, and we'll have a quick look on some of the following slides about some of the things you can do on those user estates to sort of break this down a bit. And all of the things that you can do here will help to cut down on that lateral movement or that escalation, whether it's from a user or a compromised admin. Now, like I said, it's about defense in depth. So, for instance, if we take as an example, such as WinRM, you can block Windows remote management by applying policies, or you can block Windows remote management by blocking access to the ports that it uses as well, right? Now, if you remember, we're talking about compromised admins, right? If you block the ports, right, or turn the policies on, an admin can try and turn those off. So it's always better to have multiple layers configured because, as I say, it gives them more hoops to jump through when they're trying to disable it. So, as well as having that defensive depth, you've also got to make sure that you monitor these things and apply policies to put them back to make sure that, that window that possibly a compromised admin has gets reduced as much as possible.
The WinRM conversation was an interesting one with CISO. If you want to use Packer, because that uses WinRM to talk to your cold image VM.
It does indeed. And I've actually mentioned that on my Windows RM slide because, in fact, it might have been at the same place you're talking about. We had to just put them in a separate OU where WinRM was allowed for the bakery sort of phase instead. Yeah, so it is an interesting one. But yeah, Packer uses WinRM and it is very cool when it does. But yes, let's get that. Anyway, excuse me. So obviously though, the first thing, the only bit that you really can't scrimp on, right, is all of the auditing that you need to do, right? Because as I said, a determined attacker is always going to get in somehow, right? So we want to slow them down and limit their scope, but we can't compromise on the auditing because when a breach finally happens, you've got to be able to track that back, if not for anything else apart from GDPR, right? So you need to audit as heavily as you can. I mean, don't do anything daft like keep all of your audit logs local, right? Use an SIAM tool to make sure that they all get sent centrally. Another very important thing is make sure you've got retention and rollover policies, right? Don't lose your logs or anything like that. That's a really bad thing to do. What we also need to do is, over a period of time, learn to identify trends within all of those audit logs, learn what's kind of normal noise and learn what's a change to that, which might be a possible indicator of compromise. There are lots of things you can do, but auditing is absolutely crucial. Now, when it comes down to user sessions, I think it's very important to mention that Citrix have session recording, right, which has really come on quite strongly in the last few years. And I think it's kind of almost a niche sort of product, really. I mean, you can get lots of tools that do session recording for like website levels and things like that. But as for just recording the whole session, Citrix is I wouldn't say completely unique, but it's fairly unique. And what you can do is exactly what it says on the tin. You can do it in cloud, you can do it on premises. The cloud version is probably much easier to get set up. But you can record either the entire user session, right, literally from start to finish, or you can record just bits of the user session based around particular triggers. So, for instance, a user opens a Powershell session, you can start recording that session. Now, you can do it, you can either notify them that this is taking place, or you can do it covertly as well. Obviously, from a GDPR perspective, I think it's probably a better idea to announce to them that you're actually doing it. But it's a really good tool, I think, because, just the very fact that a user would know that everything they do in their session is being recorded might well discourage some of them, from doing things that they possibly shouldn't. So I would say that if you could get it in place, and obviously if you were a Citrix customer, because although you might want to pay the license for it just to get it, I don't know. But, it is a very good thing to do because it gives you that capability to do a much better root cause analysis and obviously to have much more, sort of evidence to go through as to what you're looking at. And I don't even know as if you can train it, maybe put some automation on it even and find out if users do certain things, you can take certain corrective actions after that. So that'll be a very strong tool for you to use with regards to certainly auditing and discouraging people from trying to do lateral movement and other bits of compromise. Now, possibly the number one thing that I see which could help, your average enterprise sort of cut down on lateral movement is disable single access, right? And this is always, where you get somebody coming in, a new starter in the IT department, and they say, oh yeah, just put them in the Citrix admins group, right? So you've got all those stuff like, delivery controllers and databases and storefront and Netscaler and all of that, and that one group allows them access to all of that. Now, obviously, from a management perspective, that's all great, right? Because, you just pop them in one group. But from a compromise perspective, you've now given, if one user account gets compromised, they've got access to all those bits of your infrastructure. And I think it's important to make the same point about the domain admins group, right? Because a lot of people just give domain admins absolutely everything. And again, if a domain admin gets compromised, they've got access to your entire environment. So you have to try and really negate that a little or make it a little bit harder, right? So good OU design, so you don't need filtering on your JPOs, plate each of the components in their own containers. You can assign different firewall and admin group rights to it. Now, obviously, everybody says, right, especially if you're in a smaller company, then it becomes a pain that we've got to manage all of these components. But I think this is one of the most important things to get across to people is that they need to change the way that they do admin, right? You need to get things like privilege management systems like CyberArk and LAPS and things like that, make people work harder to do their admin. And I know in some environments, now, you've got to check out an admin account every day and somebody else has actually got to go in and approve that, right? It's got to have a second set of eyes on it. These are all things that will make your kind of posture around, sort of people being able to move laterally through the environment will make it better. And I mean, if you did it the old style way, right, if you had an admin account that had all of that access, if they get compromised, right, it's game over. He's got access to all of those systems. But if you've got a proper privilege management system in place, right, if your admin gets compromised, maybe they can log into the likes of CyberArk, right, but it'll still need MFA, right, so it's no use. But even if they gets his phone compromised as well, what you can do is then look at the trends. Maybe a user checks out, 4 or 5 admin passwords every day, but then one day inside an hour they're checking out 20 admin accounts, right? You can set up alerting around that and you can get his account disabled and stuff like that. So changing the way that users do their admin is very, very important. Quick mention for multi-factor authentication because I think it is pretty ubiquitous now, but if you're not doing multi-factor authentication, you really should be for all of your admins. It does start out as a pain. I mean, I remember when I first had to do MFA for all of the stuff that I logged into, it was a pain, but it eventually becomes second nature unless you do something crazy like I did a few weeks ago and drove over my phone in the car, and then I had to put a whole host of MFAs back on the next day, which was not very pleasant, but there you go. But yeah, there's no excuse for not enabling it, right? And you can do MFA on so many different levels, but you can do it with software, you can do it with hardware totals like YubiKey, but you can also do MFA for certain applications. I mean, I'm sure you're familiar now when you log into Office 365, for instance, it will pop up an MFA challenge every now and again, right, as it sort of re-authenticates, which you can configure on certain levels. So get MFA in as many different places as you can, and it will make any attacker's life a lot harder. Now, if you have sort of hacked into an environment or you're up to no good, right, the first thing you always want to do is run PowerShell, right, because it's like a Swiss Army knife of stuff that you'll use once you gain a foothold. So it's very important to try and secure PowerShell because, as I say, it's the first place that a hacker will go to. And there's loads of stuff you can do with PowerShell to make it better, right? Firstly, get on the latest version, right? I think 7.2 is the latest version. You also need to make sure you've got version 2 of PowerShell disabled, because you can run version 2 of PowerShell just by putting a parameter on. And the problem with version 2 of PowerShell is that it doesn't have any auditing on it, which means every command that you ran from there would not be audited. So you can simply disable that as a Windows optional feature. What I also do as well is I run that disabling of the PowerShell version 2 feature as a log-off script or as a scheduled task. So if you've got an admin who decides he's going to turn it back on because he can, then it'll get turned back off as well. You can also disable it on Windows 7 as well by deleting some particular registry keys, but hopefully nobody's still using Windows 7 apart from us at the minute. Also, what you need to do is make sure that the people who don't need to use PowerShell, right, can't use PowerShell. So, you know, you can restrict it through AppLock. You could use FSLogic's app masking to restrict it as well. You could use Cyric's app access. Don't forget there's 32 and 64-bit versions. It's not just PowerShell itself, it's the PowerShell ISE you want to disable as well. Like I said before, when we talked about how your admins are adminning, right, but not just your admins with regards to PowerShell, you'd be surprised how many users, particularly on trade floors and things like that, use PowerShell for doing all sorts of funky stuff. Make sure you understand how they're using PowerShell and if they absolutely need to use it. If you can't challenge them and say, why are you using that? Can you not use something else? You know, make sure that they get put into some sort of exception group and that you then understand and look at how they're using it and make sure that they're not getting up to no good. Tied in with that, you can set script execution policies as well, right? Allow only signed scripts and implement a proper code signing sort of methodology for your environment as well. There's an option to turn on a thing called constrained language mode, which is basically PowerShell with, you know, most of its sort of features kind of disabled. You can do it by turning on AppLock or script rules, which is quite cool because that puts it into constrained mode for everybody except admins. But if you wanted to put it on for everyone, including admins, you can run it through an environment variable as well. Just be aware that most scripts out there certainly do need full language mode to operate correctly. And probably the most important part of it is to turn on PowerShell auditing, right? There's a set of GPOs you can use, turn them all on to the max, send them out locally and just feed them up to an SIEM. So make sure if you've got users who are going around running PowerShell as a matter of course, you can sit there and audit whatever it is that they've done.
Sorry, can I just say PowerShell auditing is also useful if you're trying to debug PowerShell. So if you've got a vendor's PowerShell stuff, because a lot of vendors use it, it's great for seeing what's going on under the hood. But execution policies are pretty shit. And do you see GIA at all?
Say
just
what?
GIA, just enough administration.
No.
Anybody else come across GIA? It's a way of...
I've come across it, but nobody used it.
Yeah, well, people should do again. It's a way of giving people PowerShell, but just enough. So unlike constrained language mode, you can say who can do what, at what level, on what machines with PowerShell.
Yeah, nice. That's pretty cool. I shall add that
So
in.
like, again, Microsoft feature.
Excellent, cool. There's obviously other bits as well where users can try and sort of break into things such as the command prompt, such as registry tools, and even my personal favourite one that I find often works in environments where they try to lock down is FTP, because if you run FTP and just put an exclamation mark in front of every command, it runs them as if it's a command prompt, which is really cool in some of the environments I work in, which are really locked down really, really hard. So you can block all of these out through a variety of methods. You can use policies to do it, you can use AppLock, you can use FSLogic's app masking, things like that. Obviously, the more the merrier, right? Policies and the AppLocker blocks will give you that kind of defense in-depth strategy to stop people breaking into those other kind of command prompts and tools that might let them do damage. Now, local drive access is always a funny one because people always think, you know, why would you lock out that local drive access? And I mean, it stops users going rooting through the file system, looking for things, you know, doing a bit of reconnaissance. It possibly blocks them being able to access tools and utils, like we've just mentioned. Obviously, you block them with scripts and policies, but if you block them out the local drive as well, that gives you a sort of a third line of defense. It also stops them saving things onto local drives in non-persistent environments, which can be a DLP issue. I remember having to rebuild 1,000 Server 2016 instances once because somebody had managed to drop stuff all over them accidentally, which was not very nice. It'll also stop binary planting attacks, which we'll talk more about in a bit, and also stop them from reading system artifacts. So when it comes to locking out local drive access, the key thing to do is make sure everyone's using something like OneDrive or another EFSS or redirected folders, right? And all of their applications are saving to those. And then you can turn on the GPOs shown here that block out all those local drives. One thing to remember is if you're using the OneDrive sync client, it likes to use the system drive by default, so you either need to redirect that somewhere else or maybe just disable it, right? Because potentially you can use other things like ShareFile, like Cloud Drive Mapper and stuff like that to avoid having to have a user cache stored on the device. Now you can also break into the local drives via the browser as well, right? Basically just type in file : / and then the letter of the drive, and it'll jump in there as well. Internet Explorer is blocked by the JPO as we just mentioned previously, but nobody uses Internet Explorer anymore, do they? So that's fine. However, Chrome, Edge, Firefox, things like that, they've got their own specific JPOs. You can use those to block lists of URLs and block out those local drives as well. Now, another thing, this is not really local drive access technically, but to stop users moving through file systems on other machines is to block out UNC paths, right? So they can't go jumping around everywhere. And there is a JPO called remove the run command, which is really quite heavy because it doesn't just remove the run command, it blocks users from putting any UNC paths into the address bar. And that's quite good from a lateral movement perspective, but what you've got to remember is, again, when we're talking about how do admins admin, if they actually need to access any UNC paths, how do you provide that to them? I mean, basically, you can just give them specific shortcuts to specific UNC paths, and that'll actually work around this. But it is a bit of a funny one, especially when your administrators are used to typing in network paths. So you've got to be a little bit careful with that one. But if you want to deploy it, it will help you out. There's also the instance of loopback access where since Server 2012, a user who is interactively logged onto a machine can access the $C share on the machine, either through localhost or through the loopback address. So it's not really desired because, again, it's a bit of a backdoor into the file system. So there's a registry entry that's listed there and that is on my blog somewhere. It's a hex entry, so it's quite complicated, that can be used to set that back to the default behavior of only allowing admins access to those $C and admin shares as well. So that's quite useful to turn on. One of the other bits I find that's useful for cutting down on this kind of lateral movement capability is if you've got Windows systems, again, I think since Server 2012 or so, now all users on the C drive root get the right to create folders and append data, which means users can create new subfolders in that C drive and create a binary planting security risk or somewhere where they can save data that possibly shouldn't be there. Now, you can remove that root permission without adversely affecting any functionality. I've done it in loads of environments and nobody has ever complained that they couldn't create stuff in there. So that's a good thing to do in your image as default. But also you can run access check from sysinternals, which will go through your file system and identify any other folders with kind of weak permissions on them. So then once you've got that output, you can assess those other folders. Sometimes the temp directories and things like that have weak permissions on them as well. So again, even though you've locked out those local drives on a number of levels, we just do this to make sure if a user does find their way past that, they can't go in there and exploit anything that would let them do a binary planting vulnerability. So if you've got that kind of read and create access to those folders, on a Windows system, when you run an executable, the path variable gets queried when it tries to load its files. So basically, an attacker that's got that kind of write permission into those directories that they've created can substitute their own malicious files and attempt to have them loaded. So the programs files folder and the program files x86, program data, and the Windows directory folders are adequately protected. They have the right permissions. But if you've got an application like Puppet, I'm specifically thinking of here because this does that works with those, it goes into C:\Puppet or something like that. If you haven't changed the NTFS permissions, by default it gets those weak permissions, so you get the binary planting attack. So not only do you need to change the permissions, you also need to make sure you haven't got any applications installed that have installed the wrong areas and given you that kind of binary planting hole that's possible there. Now, I do remember once when we were having a pen test done and we'd stopped the kind of red teamers from being able to run PowerShell, and I was quite annoyed when they just actually emailed themselves a copy of it and got away with it, which was quite an amusing day actually. because we hadn't applied any AppLock policies, and the security team, in the middle of showing off to everyone about it, and somebody, well, it was me actually, applied a load of AppLock policies right in the middle of their presentation and cut them off. So AppLocker is a really good thing to use when it comes down to cutting off that execution sort of problems. Because basically, you know, you give it a list of things and you divide that up by publisher, by a hash, or by file path, whichever way you want to do it, and say these are the only things that can run on the machine. We had SRPs originally, they became AppLocker, which is a bit more granular, and we now have Windows Defender application control as well, which is like the future of AppLocker. It's more advanced, it allows blocking of kernel mode processes and device drivers and things like that, but it doesn't yet support per user policies that AppLocker does. But once it does, then I imagine Windows Defender application control will be the go-to application restriction bit. What's that, sorry? There's not many application execution things that are nice to configure, to be honest, but
Advanced application control, trusted ownership, that's what you want.
it's mentioned on there, mate, it's mentioned on there. Yeah, there are other things like policy pack, like WEM, like your anti-application control, and Guy is right actually about that. The trusted ownership is quite a nifty way of doing it, because it kind of self-configures to a degree, as long as your administrators haven't gone rogue. That's the thing. And device trust. I've actually linked an article there where I went through a load of stuff. I did actually write that article, it's got someone else's name on it, because the guy who paid me to do it obviously didn't want me to take any credit for it, so there you go. I did get some interesting emails from Carl Webster telling me that somebody had hijacked my lab. So yeah, use an application execution restriction technology, because it will cut off all of those chances for security teams emailing themselves stuff or executing stuff in other weird ways. And I mean, don't actually, an interesting point, don't rely on the internet, you know, being blocked downloads from the internet to help you out from that sort of thing, because I did once discover on a Nexus repository that was internal loads of hacking tools loaded on there that people could just go and download themselves and install them, so which was quite cool. Anyway, firewalling, on those, you know, kind of like the user estates, really, your virtual desktops and whatnot, you know, you really should be looking at firewalling things like inbound SMB traffic and probably also outbound SMB traffic, except to obviously places that you know it needs to go, like DCs and file servers and things like that. Again, RDP traffic, you shouldn't have people bouncing around via inbound RDP. There are other ways you can do sort of user session sharing that don't involve everybody just jumping around via RDP left, right and centre. I mean, for the simple reason, you know, if you restrict the way that people can access machines to do like a session sharing or user aid, things like that, you know, you cut down all the noise. So if you see people starting to RDP from odd areas all of a sudden, you will notice that it is. Again, WinRM, which we already mentioned, block that inbound and outbound unless, as you say, you've got Packer using it for the build process. So you might want to put some exclusions in for certain areas around that, and put all of those policies in place via GPO or Intune, although GPO is generally better. Actually, interesting mention about GPO. I mean, when you talk about GPO versus Intune for applying these sorts of policies, you know, Intune doesn't refresh as much as group policy does. So if you've got potentially a compromised admin who might maybe try and revert those policies and get around them, GPO is much better because it has a much more aggressive refresh interview. So the kind of window of opportunity that they have is much reduced. So that's one of the things where GPO is kind of almost ahead of Intune a bit when it comes down to talking about security. Another interesting bit that I found was, you know, especially if you're doing automation on machines, when you're doing building them, you can find artifacts kicking about in the file system that have got basically admin passwords and things in there. So look at unattained XML files, sysprep files, HCL files that you use for Packer and things like that. Make sure that you've cleaned up those install artifacts afterwards. Make sure that you've sanitized your images. There's also, slight aside, if you look in things like Office 365 and SharePoint, you know, these kind of cloud repositories you've got, you can often find things in there that you shouldn't. And Microsoft Delve actually is a really good tool for going digging and finding what sort of stuff people have access to that they shouldn't. I worked for a company once where I found everybody's salary data for the entire company when I was just digging about in Microsoft Delve. So you should really look at things like that as well and make sure your permissions are good and, you know, people aren't digging passwords and stuff out of there. A few other bits of lockdown you can do. Obviously, the Microsoft Management Console that lets you, connect to all sorts of things. You can restrict that via GPO. So when it comes down to blocking lateral movement, that's another good one. Obviously, underneath it uses things like WinRM to do the connection. But again, if for some reason your policy that blocks WinRM isn't active, then locking them out of the Management Console and things like that will have the same effect. You can do the same with WinRM, as I say, make sure all the WinRM policies are set, it's disabled, block the ports as well. You've even got things like the control panel and settings, right? You can go in there and block those out via policy. So again, don't give users or admins the opportunity to go digging around in applets in the file system that they shouldn't have access to. You can even go as far as doing a custom edit job on the WinX menu so they can't get access to the command prompt and event viewer and things like that. Like I said again, you should block that all via policy and things like that, but just to be safe, make sure that you've changed that as well. Now, local accounts, right? I've seen plenty of workstations where every desktop and every laptop and even every server in some crazy places have a local admin account with the same password. So all they need to do is compromise that password once and they can go literally anywhere, right? If you haven't got something like CyberArk or another privileged access management tool, then you can protect these. They call them Praetorian accounts is the name they chose for them. So Labs works by storing all those local passwords in AD, completely randomized, and an admin basically gets to check out the password for a limited period of time via the Labs console, which then changes it afterwards. Obviously, stuff like CyberArk is much better, right? But if you haven't got access to any of that, then it's a great start. Another thing as well to talk about is, especially on virtual desktops where they aren't mobile devices, then there's no need to save cache credentials on there, right? So only laptops should have cache credentials, and that means that somebody can't come along an attacker and start trying to crack the hashes of any passwords that are saved on the machine. It's obviously a good idea as well to delete copies of administrator profiles as well, because you usually find admin profiles are full of all sorts of interesting stuff. And also be careful, what I say a lot is you look in people's base images and they've got a stack of admin profiles stored in there that then persist onto every other instance of that image right across the environment. I think I touched on this briefly as well about network segregation, and this sort of goes into talking about how admins should admin a bit differently, right? And the idea is, Microsoft say you should divide things up into different levels of admin. So you might have Active Directory admins, database admins, workstation admins, different levels of admin. But the idea is that these admins should only do their kind of adminning stuff from specific network segments, right? So, I don't know, if you've got people who need RDP to certain workstations, if you allow everybody to RDP, right, you've got a load of RDP noise right through your environment, right, and you can't tell who's good and who's bad. But if you say only people in this particular network segment are allowed to RDP to these particular targets, right, you can then see that RDP traffic and you know that it's good. When you see any traffic outside of that, then you know that it's bad, right? So I think that's a good thing to do, to divide it up. So all the things like the WinRM, like remote registry access or anything like that, if you've got any of that turned on, right, make sure it's only done from specific network segments, and that way you'll be able to tell, what is an indicator of compromise and what's just normal noise that you expect to see on the network as people do their jobs. And that kind of brings us on to the idea of having what's called a privileged access workstation, right, which again is, rather than doing any of your admin work on your own machine, right, you have a specific machine or device in a particular place, a particular network address segment, which is where those admin tasks are done from. Now, there's two schools of thought about how you should deploy a privileged access workstation. Now, the first one, and the one that you would probably get recommended in a high security environment, is that the user must use a physical device for their admin workstation, right? And that's based on what's called the clean source principle. And it means that a system can be dependent on a higher trust system, but not on a lower trust system. So if a user has a virtual machine for admin tasks, that workstation is now dependent on the security of the hypervisor and the broker as well, and it breaks that clean source principle. So what's supposed to be is actually the admin workstation is actually supposed to be the physical device in use, which you don't log on with an admin account, you log on and then use privileged account management tools. But the kind of drawback almost with it is this physical sort of admin workstation shouldn't be allowed to access the internet or emails, and the idea is you then run a virtual machine to do all your collaboration stuff. Now that's the high security way to do it, right, and that's the kind of recommended way, but unfortunately in the real world, especially when a lot of us are working remotely, right, where we need internet access to get access to things, it makes it very difficult to do that and maintain that clean source principle. So I think a lot of people go for like the virtual privileged access workstation, or even the kind of the old-fashioned jump box as that kind of admin area. But if you're going to do it like that, I think what you really need to do is take an extreme level of hardening towards it. Some bits of which are mentioned here. Things like, you rebuild them every 30 days, you run Windows 10 and Windows 11 with full security features, you make sure everything's patched inside of that 30 days, never allow them to be admins, everything is strictly controlled, the applications that you've got on there are strictly controlled, everything's segregated through access groups, you've got MFA on there, you can't do any SSO onto there, there's no collaboration tools on there. If you're going to go down the, of having a privileged access workstation, being a virtual desktop, you need to get really, really, sort of medieval almost with the hardening that you're going to do on there. And what I've said is it does feel to the administrators when you do this, when you lock these workstations down that they do their adminning on so hard, that it feels somewhat frustrating for them. But you have to try and kind of almost sell it to them that you're doing this to sort of protect them in a way, And I mean, as admins, we've all sort of encountered more frustration, I think, over the last few years as we've had to use things like MFA and privilege management tools. I mean, I know loads of people have got text files on their desktops full of the passwords they've checked out from CyberArt and things like that, which again is another sort of threat area which we need to get down. But, we have to try and get people to understand that the reason we do this is to protect the enterprise and protect them as well, because nobody wants to be that person who gets compromised and ends up, having that kind of material loss attached to them that costs people money within the business. So, just in summary as to what the sort of key bits is that we should look at. I mean, I've banged on about defence in depth quite a lot, but, that is definitely a huge part of it. You need to make sure if one of your strategies, your mitigations fails, that you have others in there, 3, 4, 5 of them inside there to cover for the others. Again, the number one thing that I always find, that splitting up of the admin roles. I mean, I just look at my own lab and literally everything's assigned to the domain admins group, right? Yeah, it's very much a case of that I'm not practicing what I preach, but you really should, right? Make sure that those admin roles are divided up because it's just so easy to give everybody. Another thing is, right, when people create new accounts, right, they just clone them from other people's accounts and clone all of that access off somewhere else. Make sure that your join and move, leave sort of process improves so people aren't doing that. Apply as much of that hardening as you can to your user estate, right? Most of those things probably won't affect users in their day-to-day business. They're very much aimed at people who are adminning those users as well. So, there's no excuse for you not to apply a lot of those. Network segregation as well is a good thing to do. Adopt that privileged access workstation. Like I said, if it's a jump box or dedicated virtual desktops or whatever you can put in there, make sure that admins are adminning from specific areas with the right accounts and the privilege management as well. And make sure that you've got auditing. Again, session recording might be a good thing to look at. But again, the most important thing is you've got to detect, you've got to respond, and you've got to make sure that you retain all of those logs, because there's no point doing all of that sort of work just to be caught out by the fact that you haven't got the information when the time comes to do the root cause analysis. So I think I'm only slightly over time, which is good. So, if anyone's got any questions?
I've got a question for you, James.
Yes.
How do you handle browsers that save credentials? Do you just turn it off and just the users off? Because it was picked up in a recent pen test.
Yeah, that's a good point, actually.
And they were like, well, if that account's compromised, then all the browser passwords are accessible by whoever compromised the account.
Yeah, that's a very interesting point, because I was thinking about my own browser now, which I don't even clear the cache on my browser because there's passwords in there I'll never remember. Well, that's a very good question. I'll have to think about that one. It's a difficult one to, unless you've got some sort of, well, I guess if you had something like a password management tool, like a KeyPass or something like that, and you forced them to log off every night to make sure they don't stay logged into it, which again frustrates them a little bit, but at least it's only one login to get access to all that sort of stuff. Yeah, that's the way I'd have to lean. Adam's one first.
So security is a bit of a black hole, right? So you can spend as much time and resources as you actually have available on security, and there's diminishing returns on some of that. And you've given a really good overview of different security principles. And I think a lot of the time
Kill all the admins.
Well, could kill all the users. It's the easiest one. Well, that one I mentioned about making sure you don't have single user access, right, and improving the join, and move, leave process. I see so many artifacts just left behind by people copying stuff and not getting rid of things that they should afterwards, not cleaning up people's data. I think the other one I was thinking about is stuff like ad blocking in a browser. Actually, rather bizarrely, is a good sort of security posture, which I didn't actually mention there. You know, you can apply that for users, and it actually makes their performance a bit better, and it protects them from a whole lot of the crap that's on the internet. And it's one of the very few things, I think, you know, what Lee mentioned is, you know, you can secure that, but it pisses the user off. I think ad blocking in the browser is something that actually makes the user's experience a bit better, whilst also making it a bit more secure as well. So those are the sort of bits that I'd concentrate on. But I think you are right as well in that, yeah, there's a lot of stuff in there that people will... I mean, when the mention of network segmentation, right, is weird because all of our kind of old enterprise networks are very flat, right, whereas our new cloud networks are all incredibly, you know, it's not allowed to talk to anything unless you've specifically asked for it. So essentially, we've almost got to redesign them. But again, you also get that frustration with the cloud networks. You know, you put something in place and nothing works, and it takes you 6 months to get something up and running. You could stand up in 5 minutes.
Cool, thank you.
Mine was just a comment actually. A couple of items that I've seen used are Privileged Identity Manager in Azure AD to temporarily give you the admin rights you need. So that's like your tier 1, tier 2, 3. And now you can use generic groups to attach to PIM. You can say, even if like the admin access is just a server or a Citrix cloud, for example, if it's attached to a group, you can attach that to PIM to say, actually, I only want to be admin for an hour, and it'll put you in the group and then take you out the group. So it reduces the attack footprint if it's group-based permissioning, because then the users generally aren't in the group.
Yeah, there's a lot of good stuff in the Microsoft stack now.
Yeah, so Microsoft did a lot of work on that. And Microsoft also have the endpoint privilege management pack as well now, which allows you to take away the local admin rights from the users and, again, attach a workflow to give them elevation rights. But that's a chargeable thing that Microsoft do. It's part of the Intune pack add-on. It's called endpoint privilege management. So it's a bit like PIM for endpoints. So whereas PIM is targeted at administrative accesses in Azure and AD, the endpoint privilege management is targeted around the OS and being able to elevate processes temporarily or have an approval workflow to get elevation, which is limited in scope and limited in time. Final question for you, sir.
Well, more a point I'd say, if you're not doing process creation and termination auditing across all your machines, you're missing a trick, not just from a security perspective, so you can see who ran what and from where, all that stuff running out of user profile, but it's also great for diagnosing slow logons and application problems and everything else. You know, and when somebody rings in, I had a problem at 11 o'clock yesterday. Well, why did you tell me now? If your logs go back that far, you could look at exactly what happened. It's process monitored, but oh shit, I didn't think about running process monitor because you can't. It's happened. So process creation, termination auditing, plus command line. There's so much value in that.
Cool. This will tip.
Just a really quick one on your point, Neil. You can actually do a similar thing just using dynamic groups for assigning admin privileges. So you have a security group with a dynamic group inside it and place a user in the dynamic group. You can set a light spanning on the dynamic group, where it will automatically delete itself
Right.
at the time with a dynamic group. So you don't actually need the tool to be able to do it. You can do it all with Powershell and exit functionality within AD.
Cool. Useful tip. Right. Thank you, James. We now have coffee upstairs.